Yo, welcome back. Just when I know I'm going to do some math, it just makes me feel like dancing. Hey, get ready. You know me. You need to have your notebook and pencil ready to take some notes. And remember, you can always go back and listen to it again as many times as you need to. If you feel like I'm going too fast, go ahead and pause it and then get back with it. Here we go. So today I'm going to show you how to graph quadratics using the intercepts. Well, if I'm going to find the intercepts, the first thing I need to do is find the intercepts. Did I say if I'm going to find the intercepts? If I'm going to use the intercepts, I need to find them. Anyway, I'm always getting ahead of myself. All right, the first thing you want to do is let's go ahead and find the axis of symmetry. How about that? All right, so notice what I just said. If you pause it, if you need to pause it, go ahead. First step, find axis of symmetry. All right. Now, how do you find it? Well, we're going to need this. We're going to need negative b divided by 2 times a. Now, the values up here. This is a, this is b, and this is c. A refers to the number. All these refer to the number, not the variable. All right. So let's plug them in. Negative. Well, actually, that negative is 4. So I'm just going to do this on purpose just to show you. Negative 4 times 2 divided by 2 times a. A is 1. When you have two negative signs like that, we have one negative from the negative b, the formula. And then this 4 is also negative, which is going to make the whole thing positive, right? Therefore, I'm going to get a positive answer. So 4 divided by 2 gives me 2. So my axis of symmetry is 2. Let me get this graph right here. Bring it over. Let's enlarge it a bit so you guys can see. And since my axis of symmetry is 2, I'm going to find 2 on my x-axis. And I'm going to just draw a dashed line. Does this have to be done every time? No. This is because I'm teaching, right? That's why I'm showing you what I'm doing. So axis of symmetry. Remember, the axis of symmetry, that means that I can divide the graph straight down the middle and I'll have two identical sides, right? Because it's symmetrical. All right. So now that I found my axis of symmetry and graphed it, let's go ahead and find our x and x intercepts. So what I'm going to do to find the x intercepts, I need to set this whole thing to 0. And I'm going to, you know what? I'm going to factor it. So let's do this. I'll write it on this side. 0 equals x squared minus 4x plus 3. So I'm going to plug in 0 here. What does this mean? Well, that means that what two values can I multiply together to get x squared? Well, that's x times x gives me x squared. And then I'm going to have, I believe, a 3 and a 1. I need to get a negative 4, so actually both of these will be negative. So x minus 3, x minus 1 would be the factorization. Now, it's still, I'm going to set it equal to 0. What does this really mean? Is that I have x minus 3 equal to 0 and x minus 1 equal to 0. Now, let me pause for a second. I've shown you in past videos how to factor quadratics. Because right here, I did not use the X pattern, did not use my generic rectangle. That's the first thing you need to do. If you're not there yet, you don't know how to do that, please click the link. I'll put it up here somewhere, probably here. And click on and watch that video first. Otherwise, this stuff right here is not making sense to you already. You're wondering where I got it from. All right. But if you watch them, let's continue. All right. So let's solve each one. And we end up with x equals 3 and x equals 1. So those are my intercepts. That's when y equals 0, right? Because we made y the value of 0. So therefore, we have 3, 0, and we have 1, 0. Now I have my x intercepts. Let's go ahead and graph them. Let's make them in a bright color so you can see them. So 3, 0 would be here, and 1, 0 would be here. Okay? Makes sense. Look how symmetrical that is. It's right in the middle between the 2 points. So let's go ahead and find the y-intercept. Okay, y-intercept. Let's think about this. Y-intercept. If my x-intercept was when y has a value of 0, then my y-intercept should be when x has a value of 0. That makes sense? Let's go back here, and I'm just going to make each one a 0. So that x should be 0. Let's do it in a different color. That x should be 0. This x should be 0. Now, if we solve it, well, 0 squared is 0. 4 times 0 is 0. I'm left with a positive 3. That means y has a value of 3 when x equals 0. Therefore, I have 0, comma 3 as my y-intercept. All right, let's go ahead and graph that one as well. So 0, positive 3 right there. Okay, that right there is once again my y-intercept. What I need to find now is my vertex. So my vertex, where am I? Oh, one thing you should know, and write this down, people. Your vertex, your value of 3 here, or excuse me, your value of 2 here. Remember, we found this as the axis of symmetry. Well, if I was actually doing a table of values, right, x and y, that would mean that this value here, the 2, where x equals 2, that value is 2. I want to find what my y value would be, so I can put a dot on that value, and that would be my vertex. Well, simple. If this is here, x equals 2, we can take the original equation and plug 2 for it. So it will look like this. 2 to the power of 2 minus 4 to the times 2 plus 3. We get 4 minus 8 plus 3. Negative 4 plus 3 is negative 1. So the value here is negative 1. And that right there is my vertex. In this case, let's see. 1, 2. And what is that? Negative 1. Ooh, I almost went to the positive one. So it's right there. All right. So in this case, my vertex is also going to be known as a minimum. Write that down, minimum. Why? Because that's the lowest point in my graph. From there, it just expands infinitely towards the positive end, right? It continues to grow. So I have no maximum. My maximum is infinite, but I do have a minimum. My minimum is 2, comma, negative 1. That makes sense? Now I can put the line through my graph. Now pay attention here. You may wonder, well, if I go through here, connecting these points, do I just stop here? No, people. Look at this point that you have here. This point is 1, 2. It's 2 units away from my axis of symmetry. If this is symmetrical, then 1, 2, 2 points away, I'm going to have another point. Does that make sense? Now, this is one way to do it. I'm trying to show you the easiest way possible, people. That's what I do. Now, you could have created a full table of values and graphed those values. But hey, I'm trying to make it easy for you. All right? Does that make sense? Step 1. What did we do in step 1? Right here, right? We found our axis of symmetry. What did we do next? We found our X intercepts. And then I found my Y intercept. And then got my, I used that. No, not use it. I got the 2 from my axis of symmetry to find my, in this case, my minimum, right? That minimum right there, my vertex. All right. If you missed anything at all, please go back and play back. Look, it's only 9 minutes long. Come on, people. Hey, like always, if you got value out of this, please hit the like and subscribe button, all right? And I'll see you next time on Math Quest. Goodbye.